Welcome to The Explainer. Today, we're diving into something pretty different. We're not breaking down some stuffy academic paper. Nope. We're looking at a blueprint for a revolutionary new way to think about medicine. And it comes straight from the mind of a scientific rebel. And this one line, this tells you everything you need to know about the vibe here. That's not the careful language of a professor, right? That's the voice of a brilliant engineer who just sees the answer. And that confident, rebellious mindset is exactly what we're going to unpack today. All right, so here's our game plan. First, we're going to get inside this rebel's head, understand their whole method for checking if science is actually practical. Then, we'll see that method in action with a super antiviral concept. From there, we pivot to the big one, cancer. We'll lay out the entire blueprint, show you how it's all based on real-world tech, and then leave you with a pretty massive question about what's next.
So first things first, this isn't about throwing out amazing science. It's the opposite. It's about taking these brilliant, cutting-edge ideas and, like the author says, tightening the bolts. It's a sharp, no-nonsense look at how to get these incredible concepts out of the lab and ready for the real world.
Okay, before we get to cancer, we need a quick tutorial in this way of thinking. Think of this next part as our case study. We're going to watch how our source takes a really powerful idea for an antiviral and then makes it smarter, stronger, and way, way more efficient. And this slide lays it out perfectly. On the left, you've got the reality check. A proposed antiviral needs 2,000 different guide molecules to work. That's just a huge, completely impractical dose for a person. But look to the right, at the fix. Instead of brute force, it's about being elegant. Find the 200 guides that do almost all the heavy lifting, and boom, the dose is suddenly 10 times smaller. It goes from a theoretical what if to a practical let's go. In that right there, that's the whole method in a nutshell. It's not about criticizing ideas. It's about finding the one practical bottleneck, the weak spot, and then engineering a smarter way around it. Now, keep that framework in your head because we're about to turn in on one of the biggest challenges we've ever faced. So it's time to pivot. We're taking that exact same problem-solving blueprint we just learned, and we're aiming it at a whole new enemy, cancer. Now, I know, viruses and cancer, they seem like totally different things, but our source sees this incredible overlap in how they operate. And here's the connection. Our source points out that both viruses and cancer are basically masters of espionage. They hijack our own cells, they use cloaking devices to hide from our immune system, and they create these safe zones where our body's defenses just can't get to them. So yeah, different enemy, but they're using a very similar playbook. Which brings us to the main event, the neo-oncolytic blueprint. Now, this isn't about finding one single magic bullet. Think of it more like a multi-stage battle plan. It's a strategy that takes all those lessons from fixing the antiviral and uses them to build a totally new kind of weapon against cancer. Component number one is a piece of tech you're probably already familiar with, personalized mRNA vaccines. Yeah, it's the same basic idea from the COVID vaccines, but instead of targeting a virus, it trains your immune system's T cells to hunt down your specific cancer by its unique genetic fingerprint. It's like giving your immune system a heat-seeking missile that only locks onto your tumor. Next up in the arsenal, oncolytic viruses. And these are basically cancer-eating bugs. Seriously. We're talking about real viruses that are engineered to do two jobs. First, they hunt down and blow up cancer cells. And second, that explosion acts like a giant flare, a distress signal that calls in your entire immune system to come and finish off the rest. And now for the rebel twist, self-amplifying RNA, or saRNA. Remember how the antiviral fix was all about efficiency, getting more bang for your buck? Well, this is it. Instead of a one-and-done message, this RNA actually makes copies of itself once it's inside the cells. That means you can use a smaller initial dose to get a much bigger and longer-lasting immune response. It's that same principle of smart engineering, just applied to cancer. So how does this all come together? Here's the protocol. Step 1, you sequence the patient's tumor to find its unique mutations. Step 2, you create that self-amplifying RNA payload loaded with the tumor's code. Step 3, you use those oncolytic viruses like a Trojan horse to deliver the payload right into the tumor. And finally, step 4, you light up the immune system, getting it to hunt down and destroy every single cancer cell that's been marked. It's a beautiful, multi-stage precision attack. Okay, I know what you might be thinking. This all sounds a little bit like science fiction, right? Well, this is where it gets really mind-blowing. Let's talk about why this entire blueprint is built on technologies that aren't just possible, they're already here. Let's start with this number, 49%. That's not a theory, that's a real-world result from a trial by Moderna and Merck.
For high-risk melanoma patients, adding a personalized mRNA vaccine cut the risk of the cancer coming back or death by almost half 5 years down the line. That's a huge deal, and it's just one piece of this blueprint.
And look at this table. It lays everything out. Those personalized mRNA vaccines, already in late-stage trials. Things like CAR T-cell therapy, already approved for some blood cancers. Those oncolytic viruses, approved for melanoma. Even the more futuristic-sounding stuff, like tumor-treating fields, that's approved for pancreatic cancer. The point is, the building blocks for this revolution aren't on some distant drawing board. They're already in the clinic. So the real genius here, the real revolution, isn't about inventing one single thing from scratch. It's about having the vision to stitch together these incredible next-generation technologies that are already working. The Rebels blueprint is all about combining them to create something way more powerful than any single part on its own. Which brings us to our final, provocative thought. We've seen the method, we've laid out the blueprint, and we've seen that the technology to actually build this thing isn't science fiction. It's real. So I'll leave you with the same question that's at the very heart of all this. The blueprint is on the table. The tech is already here, and it's working. So the question is, what happens when the rebels win?